All right, so let us go ahead and discuss amides. Amides are a derivative of carboxylic acids. At least they have a very similar structure. CONH2. So, amides, for like the first time since we started discussing suffix groups, these have a lower priority than another suffix group. So, our carboxylic acids are the highest. Amides come below that, but they are above the next highest, which was the aldehydes. So it will be easy to discuss the suffix group convention and the prefix group convention for amides. Okay, so if they have priority, and there's no easy way to do that, so let's just go ahead and erase. I clicked the eraser. Alright, so we erase. Okay. So when they have priority, they have the suffix group. When they don't have priority, they are a prefix group. Okay, so of course, oleic acid for that prefix is carboxy. Amides are amide as a suffix group. And as a prefix group, they are carb-am-oil. Which, sounds sort of like the villain from the Smurfs. But of course, the amides can also, just like the carboxylic acids, they can also occur in, with more than two on a chain, and they wanted to take that into account. So this, just as this becomes, carboxylic acid when there's more than two, this becomes carboxy amide. Not carboxyamide, just carboxamide. Okay, so they change in a very similar way. Instead of carboxylic acid, they become carboxamide. Okay, for the amides. All right, so we'll go ahead and we'll try to discover as many of those as we can. So, all right, that's a good quick way to erase. I'll keep that in mind. All right, so now let's just look at the exceptions before we get to the rules. So the smallest possible is this guy. It probably looks very familiar. 1 carbon. Say so. Normally, technically this should be meth because there's only one of them. No double bonds. So and then amide. So it should technically be methanamide or methanamide. I don't really care too much about pronunciation. But, of course, these are common names that stick around. So similar to formaldehyde and formic acid. They are formamide. Okay. So just to recognize it, I doubt you will remember it too incredibly well. In a similar vein, we have CH3CONH2. This has 2 carbons, so it should be ethanamide. But of course, there is the common name acetamide or acetamide because it has, that 2 carbon group there. That gives it the acet. And then we have benzene with its common name, which is benzamide. Okay. Why? Because that's just the way things are. Okay. So you just get to remember common names. You don't have to use, you don't have to use formamide or acetamide, but it would help you to be able to remember them. Benzamide or benzamide, that's not going anywhere. So you should definitely not just recognize it, but remember it. All right. So let's look at some examples real quick. Okay, nice and simple, nothing too fancy about this. We have 1, 2, 3, 4 carbons. And recall, these carboxyl groups always come at the end of a chain. So very often we don't need to number them. When there's 1 or 2, we definitely don't need to number them. So this right here, 4 carbons, no double bonds, but and amide. Okay, butanamide. It's not going anywhere. Okay, and because it has priority, number 1. And in the same vein, when there's a second one on the other end, and this would be butane diamide, or butane diamide. Okay. Because they come at the end of the chain, they're always at the end of the chain. You never have to worry about numbering just 1 or 2 if they have priority. And you'll notice that the E starts showing up when we have 2 of them. That's the way we do that. That's how it rolls. Okay, when we have a di or a tri or something like that for a suffix group, then we put the E back on. So now let's go ahead and look at some slightly more complicated examples. Alright, nothing, this is more complicated, but it's not too fancy. This guy is still on the end of the chain, and it has priority, so 1, 2, 3, 4, 5, 6 carbons. This is a chloro group, and then we have here just a double bond, so that's going to change, we're going to have an ene going on there. And this is priority, so amide. Then we have our double bond. This one's easy to tell. The heavier ones are on opposite sides, so it's E. So it is E for chloro, hex 2 enamide. All right. So there's nothing too outrageous about these guys. It's, what do you call it? Just a rather straightforward evolution of stuff we've already seen. Okay, so okay. So we'll just leave this as is. It's a diamide. Okay. Remember, when you have suffix groups, you want to get as many of them as possible on the main chain. So here is our main chain. Okay, going from that end to that end. And will we number it left to right or right to left? That depends on these guys, an ethyl group and a methyl group. Okay. So 1, 2, 3, 4, 5, 6 versus 1, 2, 3, 1, 2, 3, 4. Numbering it from this end gives the ethyl a 4. Numbering it from the other end gives ethyl a 6. So, because ethyl is the first alphabetically, that's one we care about in terms of numbering. So, it's going to be this chain 4 ethyl, 5 methyl, nonane diamide. Okay, let's go with that. Okay, nonane diamide. So, once again, fairly straightforward. Nothing too bad about that. Now let's look at it with some other complexities. Okay, here's the complexity I wanted to look at. Okay, just like amines, amides can take stuff bonding on the far end or onto the nitrogen itself. So you can get primary, secondary, tertiary, and so on. So now we need to number both of these guys. Okay. So this is going to be a prop 2 il, and this is an ethyl. So when it comes to numbering, the amides themselves are at the end of the chain. So we ordinarily don't care about them too much. Or at least they're both identical, so neither one can really get priority. But the side chains coming off of their nitrogens have to be distinguished, okay? Because we need to say this ethyl over here is on one of the nitrogens, this prop-2-il is on the other nitrogen. So now we have to number them. The ethyl is going to come first, so we're going to do what we can to give it a smaller number. So just like with amines, these guys get N ethyl, N prop 2 il, and then it's going to be heptane diamide. Okay. And of course, the way we distinguish between the two nitrogens is with superscripts. So N1 ethyl, N7 prop 2 il, to indicate that the ethyl is attached to the nitrogen that is attached to the first carbon, and the prop 2 il is attached to the nitrogen that's attached to the 7th carbon. We use superscripts for that, both with amines and amides. If we have to. If there's only the one nitrogen, then we don't worry about it quite so much. Okay, so next up we have, what do we have? What are we looking for? Oh, yes, this is what we're looking for. Okay, now we get to treat the amide as a prefix group. It no longer has priority. This is a carboxylic acid over here on the left. It has priority. So now 1, 2, 3, 4, 5, 6, and then we stop counting. Because just like with carboxylic acids, when these things lose priority, their carbon no longer counts to the length of whatever chain they're attached to. So this is going to be a 6-carbamoyl. That's the prefix name for these guys. Hexanoic acid. Oops. Okay. So nothing too frightful there. You already have some practice with carboxylic acids for this, so hopefully this won't throw you for too much of a loop. let's go ahead and look at, a similar sort of case. Okay, this might look familiar. This is very similar to 3-hydroxy propane 1,2,3-tricarboxylic acid, or citric acid. Only instead of having a tricarboxylic acid, this is going to be a triamide. So we have the exact same situation. None of these carbons are going to count to the length of the main chain. Instead, we have 1, 2, 3. And then this, and this are going to be called a carboxamide in the name of the molecule. So now it is 2-hydroxy. That's this guy here, the OH. Propane, because only 3 of those carbons are counted toward the lengths of the main chain. Dash 1, 2, 3. That's a comma. Tricarboxamide. And that is all she wrote right there. So again, nothing particularly new. Okay. So hopefully amides won't throw you for too much of a loop. I mean, granted, they can be more complex than carboxylic acids just because you can put multiple things on each of the nitrogens, but that's such is life, as it were. Okay, so that is it for amides, and I will see you around.